Hey guys. So today we are going to learn how to do the 2007 AP Calculus problem involving the mean value theorem.
I'm the assistant. What is the problem?
They give us some starting information saying, let f be a twice differentiable function such that f2 equals 5 and f5 equals 2. Let g be the function given by g of x equals f of x.
Part A asks why there must be a value for c between 2 and 5, that the derivative of f of c equals -1. So, using the MVT, we get b equals 5 and a equals 2. Then, f of 5 minus f of 2, over 5 minus 2. This equals 2 minus 5, over 5 minus 2. But why the top 2 minus 5? Because, as stated earlier, f of 2 equals 5 and f of 5 equals 2. Then this equals -3, over 3 which equals -1. Part B asks us to show that the derivative of g of 2 equals the derivative of g of 5. And to explain why there must be a value k between 2 and 5, since the second derivative of g of k equals 0. Since we know k is a constant and g of x equals f of x, then we can use the chain rule to find the derivative, into the derivative of g of x equals the derivative of f of x times the derivative of f of x. Then we are able to plug in 2 for x then 5 for x and we'll get these answers. The derivative of g of 2 equals 0 and the derivative of g of 5 equals 0. So, since the derivative of g of 2 and the derivative of g of 5 both equal 0, we can conclude that the derivative of g of 2 equals the derivative of g of 5. There'll always be the second derivative of g of k equals 0. And there must be k between 2 and 5. Part C asks us to show that if the second derivative of f of x equals 0 for all x, then the graph of g doesn't have a point of inflection. Using the first derivative from the chain rule, we find the second derivative and we get this. Using the second derivative, we then plug in 0 for every value of x. Keep in mind that the second derivative of f of x is equal to 0. So we solve and get the second derivative of g equals 0. Since the second derivative of g of x has no sign changes, g of x has no POI. Part C asks us to explain why there must be a value r between 2 and 5 if h of r equals 0 and if h of x equals f of x minus x. Using the equation given in IVT we plug in the intervals, 2 and 5. We solve and get h of 2 equals 3 and h of 5 equals -3. H is differential and therefore continuous. Since 0 is between -3 and 3, by using IVT, h of r can equal 0.
There is a solution. Wow!